All right, we're going to take a look at 2017 AP Calculus AB free response questions. And we're going to start off here with number one. This is a graphing calculator question. So make sure you have your graphing calculator ready. And we're starting off with a kind of unique volume area question that they did this year. You know, as we started seeing in 2016, the questions kind of strayed away from just your standard volume questions to the more unique questions, or not as direct. So it tells us that the tank has a height of 10 feet. All right, the area of the cross section, the horizontal cross section of the tank at height h feet is given by the function a, where a of h is measured in square feet. This is actually a key thing here. This horizontal cross section. All right, when you first learn volume, volume is actually the integral of a of x dx, or dy, depending on if we're dealing with a of y. But this is the area of the cross sections. And a lot of times we kind of get wrapped up with this whole idea of volume is disk, washer, shell, that's it. But in this case, you got to remember that volume is much more than that. It's just the integral of the area of the cross section. With disk, its cross sections are circles. So that's pi r squared. That's where the formula comes from. All right. In this case, they're telling us that the area of the cross section is this function. Okay. So they also tell us that function a is continuous. That's important, and decreases. Now, if they're telling us it's decreasing, we have a table here, and a lot of times that tells us that we've got to look out for maybe an overestimate, underestimate type problem. So our first question here, they tell us to use a left Riemann sum. Now, if we see the word Riemann, we always replace it with rectangles. And we're doing the three subintervals indicated to approximate the volume of the tank. Well, here we have it. We're going to set up an integral to find the volume, and the volume is just the integral of the cross-sectional area, which in this case is just going to be that a of h dh, and h is changing from 0 to 10. So we're just going to use a left Riemann sum to figure this out. So left Riemann sum, I like to draw it. You got 0, you have 2. The left one is going to be the 0, so 50.3. All right, so that first one is going to be 2 times 50.3 plus 2 to 5. So I'm going to use the one on the left, which is 2, so 14.4. So that's going to be 3 times 14.4 plus 5 to 10. And again, we're using the left, so 6.5. So that's going to be 5 times 6.5. Okay. Indicate our units of measure. We are dealing with volume. Volume is always cubic. And so in this case, if a of h was square feet, all right, this is actually going to be cubic feet for volume. Okay, volume is always in cubic. Okay, and that's all we'd have to put. Even though it's a calculator question, we don't actually have to evaluate this because it is a free response question. So I'm going to leave it just like that. Now, the part B on this is, does it give us an overestimate or an underestimate? Okay, well, that's why we circled the decreases here in the beginning, because if this function is decreasing, you know, we can see from the graph that I drew that this is going to be an overestimate. And so I'd say overestimate because a of h is decreasing, and a left Riemann sum was used. Maybe don't need that last part, but I always like to include it. All right, so that's the big part here. So with this, we're looking at already a good chunk of points by just having those key pieces down. And they came back this year and they were all super upset because, like, what is this? We don't know what this is. And after we looked at it, they're like, oh, okay, well, even if they didn't know what to do, they could have done the left Riemann sum and they could have done the overestimate very easily. Now, part C now switches away from the table. It says the area in square feet of the horizontal cross section at height h feet is modeled by a new function. It's given to us by this f of h. Based on this model, find the volume of the tank. So it's actually the exact same situation as our part A. The only difference is now we actually have a function for that cross-sectional area. So I'm going to do the same thing that I did for part A. I'm going to set up an integral from 0 to 10 of this f of h dh. Okay, and because it's a calculator question, I'm going to go right to my calculator. And I'm going to put this right in there. Let me get this stuff off here. So, all right, so we're going to do an integral from 0 to 10 of 50.3 divided by, make sure you use parentheses, e to the 0.2, we're just going to use x since our calculator likes x, plus x, bam, that is our volume. So 101.3 decimal places, so 325. And they want us to do units of measure again, so that's going to be cubic feet again, because we're dealing with volume again. Okay, so nice thing about the calculator and just understanding that whole volume is just the integral of the cross-sectional area. All right, so D, now they switch gears totally. And for everyone's favorite, it's a related rates problem. Woo-hoo. All right, so water is pumped into a tank. Okay, when the height, so here's a when piece, and whenever I do related rates, we look for those four things. We look for a given rate. We look for the rate we want to find. We will look for the when piece, and we need an equation. So when the height of the water is 5 feet, the height is increasing at a rate of this. So that's our dH over dt. We're going to use that somewhere. So feet per minute. All right, I'm also going to go ahead and say h is 5 feet. Using the model from part C. Now that's an important piece because that's something that we need to use here. Find the rate at which the volume of the water is changing with respect to time when the water is 5C. So we actually want to find the rate of the volume of the water. So we want to find dV over dt at that time. So we need an equation. They want us to use the model from part C. Well, we know C, they gave us the area, cross-sectional area. We need an equation for volume. So let's think about that for a second. To find the volume, we did the integral of the cross-sectional area. So we're going to go ahead and do the integral of that f of h dh. But here's the thing, we're going to go from 0 to whatever height they ask us. That would actually give us the volume at some different height between 0 and h. So that gives us an equation. So let's now take the derivative. And when we take the derivative, we get dv over dt equals, well, here's the thing. You take the derivative of an integral. We're going to use a little fundamental theorem of calculus part 2, my favorite. And when we do that, we plug in the h, which gives us just f of h times the derivative of h, which is 1, minus f of 0 times derivative of 0, which is 0. So it's really just going to give us f of h. But you got to remember, when we take a derivative, we use it with related rates. We're now also going to put that dH over dt, just like we would, because h is being, you're taking the derivative of something with h, and you got to put that dH over dt after. So what do we know? We know that h is 5. So this is going to equal f of 5 times, we know dH over dt they gave us is 0.26. So now all we have to do is actually figure out what this is. So let's go back to our calculator. All right, so I'm going to do 50.3 divided by parentheses e to the 0.2 times 5 plus 5. And then I'm going to do times 0.26. And that gives us our rate of 1.694. And this would be dV. dV is in cubic feet over time. Time is measured in minutes. So we'll make sure we have our units, because in this case, I believe the units, you needed all the units to get the point for this one. So if it says indicate units, you need to make sure you have your units. And this one isn't a bad one. Everything is volume. Volume is cubic. And then you just had to make sure you match up your derivative. So volume V is cubic feet, and then the denominator was time, so we put minutes. And that was all of our question number 1 for 2017.